Good morning.
Morning, sir.
Good morning, Raja. Dhanush,
Sir, சொல்லுங்க sir.
have you submitted the lab assignments? Is
Sir,
it
yes, sir. I
clear?
have submitted it yesterday itself, sir. So yesterday morning
Okay, ma'am.
after.
Okay, very good, very good.
Sir,
As
I
usual, we
thought
can wait
both
for.
the classrooms as the same, and I so that I
Yeah,
submitted, sir.
I have understood. I have understood. That
Okay,
is
sir.
why I told you to convey.
Sir, yes, sir.
So the second hour, you will be having a tutorial session. Okay. As I said earlier, the question as well as the notes. The notes I have uploaded in the Google Classroom. Have you seen that, Raja?
Yes, sir.
Yes, sir. We received, sir.
And also three notebooks. So one is very local author book, very local author, and another one is the two textbooks. One is our textbook, the syllabus textbook Swanee, okay, and another one is Tom Denton, okay, Automotive, Electrical and Electronic Systems by Tom Denton. So you have three notebooks, okay, so you can refer any of the books, okay, and you have to submit it in the second hour itself. There is no other time given, okay. So probably you all might have received this continuous assessment test timetable. Have you all received it?
Yes, sir.
So up to which portion we shall keep? For 1.5 unit, shall we fix it? Raja? 1.5 unit, shall we fix it? I will be showing you the syllabus, so you can suggest me up to what portion we can do it. Okay. So whether my screen is visible to you all?
Yes, sir. Received, sir.
Okay, Raja, you tell me up to which portion shall we keep? So this is the first unit. Okay. Up to which portion we can keep? Shall we keep it up to thermocouple or up to strain gauge we can keep it? Okay.
Yes, sir.
So nearly 1.5 unit will be completing. Okay. So the next hour will be the tutorial hour. Okay. I have also posted the question. Okay. Before CAT exam, we are instructed to conduct 2 tutorials. Okay, Papa? So you can submit it accordingly, and we have to provide the tutorial mark to the HOD. Okay. So based on that, you have to submit it. Okay. So before CAT exam, we have to conduct two tutorial. Okay. So that is the instructions we got from our HOD, and we have to submit the mark. Okay. Every marks we have to submit it. Okay. I request everyone to submit on time. The second hour itself, the question is very simple. Okay. So you can write it. Okay. So the question will sharply open at 9:55. I have given the time at 9:55 a.m. but it is accessible from 9:55, and you have to submit sharply by 11. I have given the time duration will be up to 10:45. So I have extended the 15 minutes. Okay. So I have extended up to 11 a.m. Okay. So you have to submit it before that. Is it clear? Is it clear, Pa? Raja, is it clear?
Yes,
Am I
sir.
audible?
Yes, sir. Sir, yes, sir. Yes, sir.
So everything I have given the posted the materials. The only thing you have to sit and write it in a A4 sheet, and you have to submit it. Okay. So for CAT examinations, you will be allowed to write 50 objective type questions. Okay, 50. Is it clear?
Yes, sir.
So the 30 questions from for unit 1 and 20 questions from unit 2. unit 2 means half of the unit 2 up to strain gauge. Is it clear? Is it clear?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Okay. So now we can start and see about an important topic that is called as the strain gauge. So in the earlier classes we have seen about the potentiometer, RTD, thermistor, thermocouple, and now we can see about, so this thing also we have completed, right? RVDT and LVDT. What do you mean by this RVDT and LVDT? Tell me. RVDT and LVDT. Have you ever studied this topic? Anyone? Anyone? Have you ever heard about
Sir,
this topic?
LVDT stands for Linear Voltage Differential Transformer.
Linear variable differential
Variable.
transducer or transformer.
Yes, sir.
Okay. And for RVDT,
Rotary Variable Differential.
rotary
Rotary
variable differential
variable
transducer.
differential transform.
Okay. I can hear the background noise. Somebody is in the marriage hall or temple. Where are you, Raja? Still you are listening the
Sir,
class
in
means
my
it
home,
is
TV sound, sir. I will reduce it. Sir.
TV sound. Okay. So can you please reduce the TV sound and concentrate in the subject?
Okay, sir.
Okay. Okay, Raja. So now we can see about the strain gauge. Okay. So what do you mean by this strain gauge? In the lab class, we have seen about the strain gauge, right? So this is the the strain gauge. Okay. So this is the actual strain gauge. It consists of two types. One is the half bridge strain gauge and full bridge strain gauge. See here, this is the half bridge in which the circuit is in half completed. And see here, this is the full bridge circuit. So it is fully closed. Okay. For half bridge, it consists of 3 pins. Okay. 1, 2, and 3. See here, for full bridge, we have 4 pins. Okay. Is it clear? So let us see how it is used and where it is used. Okay. So this is the strain gauge. So this is the actual strain gauge that we are using for measurement. Okay. It consists of two types. One is half bridge and another one is full bridge. For half bridge, it consists of 3 pins, and for full bridge, we consist of 4 pins. So you may expect an objective type. For in a full bridge strain gauge transducer, how many pins are there? You may expect. How many pins are there for full bridge? Raja? Am I audible? Can you hear me?
Yes, sir. Audible, sir.
Why now? Why you people are not at all interested? I'm not able to get the proper feedback. Why? Is there any signal problem? Is there any signal problem? Arun? Arun? Is there any signal problem? Nivedita?
No, sir. No, sir.
Then why you are not opening your mouth? Tell me, today Wednesday, you will not talk to anybody else? Okay, so this is the morning first hour. I need full cooperation, right? Okay, so this is the strain gauge. It consists of two types. One is the half bridge strain gauge and another one is the full bridge strain gauge. Okay, so listen here. So it consists of filaments that is placed inside the coil. So here, let us zoom and see here there is a filament. Okay, so there is a filament that is placed inside this sheet or wafers like arrangement. Okay, so this is the filament. Okay, so it is the filament may be classified into two types or many types. You can see it as single element, which consists of the metal foil, and two element here, and three element. This is the bonded foil gauge, that is the strips that is placed inside this wafer. Okay, that is strips, that is the strip placed inside this wafer. Okay, so this is used for torque. Okay, for torque measurement. Okay, so this is the thing. Now let us see the working principle. Okay, this is the, now let us see the working principle. The strain gauge is an active or passive type of transducer. Tell me. Strain gauge is a passive type of transducer. Is it clear? Which converts
Yes, sir.
the mechanical displacement. What do you mean by this mechanical displacement? What do you mean by this mechanical displacement? Into a okay, the strain gauge is a passive type of transducer which is used to convert the mechanical displacement into a change of resistance. Okay, so that this is the passive transducer. What do you mean by this passive transducer? Whether we require any power, whether we need to supply any power for the passive transducer? Raja?
No, sir.
No. Okay, we need not supply any power. So that is called as the passive transducer. Okay, so it is a thin. Have you ever seen wafers in the shop? Wafers பார்த்திருக்கீங்களாப்பா கடையில? So it is a thin wafer like substance. Okay, it is a thin wafer like substance. Okay, which is this element can be fixed or pasted in object that we are going to measure. Okay, this is a wafer like arrangement. It is a wafer like device which can be attached or pasted or attached by the suitable adhesive. What do you mean by this adhesive? Means the paste, okay, or gum like arrangement, adhesive, to measure the applied strain. Okay, so this is a wafer like device. Okay, so it is used to attach on the substance that we are going to measure. Okay, or to measure the strain. Okay, so that is called as the strain gauge. Okay, and also when some object or some stress is happening on this material, or let us see here, suppose if we apply force on this material, what it happens when we apply certain amount of force on this area or this end, what it happens? என்ன ஆகும்பா? It may என்ன ஆகும்னா இங்க இருந்து டிஃபார்மேஷன் ஆகும் இல்லையா? Certain amount of bending will occur. Okay, so certain amount of deformations will occur, that is the bending will be occurring. ஓகே, இது வந்து என்ன ஆகும்னா இப்படி வந்து பெண்ட் ஆகி நிக்கிறோம் ஃபோர்ஸ் அப்ளை பண்ணும்போது இல்லையா. now ஐயோ so there will be a bend like structure. Okay, when we apply some material, when we apply some strain or stress, what it happens, there will be some deformation. Okay, so whenever we get a deformation on the strain gauge, the stress is occurring, or due to stress some deformation is occurring. Okay, so also what it happens means, this stress will cause an increase in the resistivity. Okay, so this stress will cause in the increase. When we apply some force on this material, what it happens, the resistivity increases. Okay, what happens when resistivity increases, there will be a change in electrical signal. There will be a change in the electrical signal. Is it clear? So when we apply some stress on this material or wave or this strain gauge, what it happens, the resistivity of the material get, or the connectivity get increases, and due to that resistivity, what it happens means, there will be a change in the electrical signal. Okay, so the change in the electrical signal can be measured. Okay, suppose this strain gauge is used for measuring very high change in resistance. Okay, and this change in resistance, so have you ever heard about the term called Wheatstone bridge? I think you all might have studied in physics.
Yes, sir.
Wheatstone bridge. If what it happens in the Wheatstone bridge, so the same circuit will be here. Okay, the same circuit will be here. There will be some resistance. Okay, there will be some resistance. Okay, the same, this is called as the Wheatstone bridge. Okay, the resistance or the change in resistance is measured using the Wheatstone bridge circuit. So the how I think this strain gauge is also connected using this Wheatstone bridge network circuit. Wheatstone bridge circuit. Okay, why we are using this Wheatstone bridge means, very small change in resistance can be measured. Okay, so there will be some objective question. Okay, important MCQ. Okay, so dash circuit or the dash is used to measure very small change in resistance. Okay, so the answer is Wheatstone bridge circuit. How this Wheatstone bridge circuit? Here it consists of two gauges and two gauges and single gauge, right? There are four active gauges. Okay, four active gauges for the full bridge circuit and two gauges for the half bridge circuit. Okay, so in half and quarter circuits, the bridge is completed with the precision type of resistors. Okay, we can get very exact precision or the very accurate results by using a precise resistors. Okay, and also we are going to introduce another term called gauge factor. So this factor is very important. Okay, so let me identify. See, listen, gauge factor. Okay, the sensitivity of a strain gauge is described in terms of a characteristics. Okay, called as gauge factor. This is very important. Okay, is it clear? So how we can define this gauge factor means we can define it as it is defined as unit change in resistance per unit change in length. What do you mean by this is strain? Have you ever heard about the strain in mechanical deformable bodies? What do you mean by strain?
Sir, the ratio of change in dimension to the original dimension.
Change in length by the original length. Is it clear? That is del L by L. Okay, so here in this gauge factor we can represent the gauge factor as G, that is the change in resistance divided by the change in length. Okay, is it clear? Is it clear? It is defined as the change in resistance per unit change in length. Okay, so this is called as the gauge factor. So this gauge factor is relevant or correlated with the Poisson ratio. What do you mean by this Poisson ratio? What do you mean by Poisson ratio? Have you ever studied? Bro, படிச்சிருக்கீங்களா? Poisson ratio, mu is equal to stress by strain, which will be 0.6, 0.5, 0.4. Have you ever heard about this? So this gauge factor can be represented as 1 plus 2 times of Poisson ratio. Okay, suppose if we are using the metallic foil means what here? See, this is the foil structure. Okay, if suppose this is the foil that is placed inside this wafers. Okay, so suppose if we are using this metallic foil gauges, what it happen means the gauge factor will be taken as 2. Is it clear? Now when the stress is applied on this, when we apply stress on this material or this gauge, okay, there the resistance takes place and there is an unbalanced signals in the Wheatstone bridge, as I said earlier. Okay, this change in resistance usually less than 0.5 percentage. Okay, it is usually 0.5 percentage. Okay, is it clear? Now the change in resistance per unit length is called as what? The change in resistance per unit length is called as, just now only I have said, the change in resistance per unit length is called as gauge factor. Gauge factor. Okay. Now the strain and the gauge factor, we have some certain relation. Okay. So similarly, the change in resistance per unit resistance is proportional to the strain, that is summation of epsilon. Okay, it is expressed as delta R by R. So that is the change in resistance per unit resistance. So this is how it represents. Okay, so this is the change in resistance per unit or one resistance, right? Therefore unit resistance. Okay, that is equal to gauge factor into strain. Okay, now we have different types of strain gauges. What are they? So before that, I request everyone to attend the poll. Energy. Huh? உனக்கு என்னப்பா ஆர்டிடியா? Question is adjustment of sound in tape recorder is done by, okay, done. There is a spelling mistake. Okay. So what is the answer? Only out of 46, 31 students have answered the poll. Okay, so I'm closing the poll. Okay, tell me what is the answer for this? Adjustment of sound in tape recorder is done by using potentiometer transducer. Okay, So many students have answered. Out of 33, 13 students have answered as RTD. So the RTD is used for measuring temperature. Okay. So now let me post another simple poll. You can answer this. Let me think how much you have understood. Completed. Only 24 students have answered. One minute time. One minute time. Thirty-seven students have answered. Okay. So I am just ending the poll. Time completed. So how many secondary windings are there in LVDT? What is the answer? Yeah, what is the answer? Two. Two or three?
Sir, 2.
Yes, the correct answer is two. Okay. So now let us see the different types of strain gauges. So can you not able to see my screen?
Yes, sir.
Now we can see the different types. So based on the working principles, number one, it is classified on based on the working principle. Okay, it is classified into mechanical, electrical, and piezo electric. Okay, so based on the working principle, okay, the strain gauges are classified into three types. One is mechanical, electrical, and piezo electric. And number two, based on the mounting. Based on the mounting, we have two types. One is bonded strain gauge, and another one is unbounded strain gauge. Okay, so these are the two types. One is the bonded strain gauge and another one is the unbounded strain gauge. Okay, now and another method that is based on the construction. It is classified as foil strain gauge, and another one is semiconductor strain gauge, and another one is photoelectric strain gauge. Okay, so as you see this, so this operations or this strain gauge is available on different gauge size and it can be utilized in various shapes. Okay, and also this metallic filament, okay, this metallic filament consists of many types of arrangement as I shown here. Okay, many type of arrangement that is shown here. Okay, when we see the pattern, what do you mean by this pattern? ஒரே அடுக்காக, சரியா, ஒரே pattern காமனான ஒரு structures, that is called as the pattern. Okay, the grid pattern inside this element, what it happens means the maximizes the amount of metallic wire. Okay, maximizes the amount of metallic wire and the strain is strain applied. Okay, here the strain applied will be in direction which is parallel to the metallic wire. Okay, so the grid, that is the grid is bonded to a thin backing called carrier. Let me write it so that you can further understand. The grid type of the grid is bonded to a thin backing called carrier, which is attached directly to the test specimen. Okay, is it clear? Now we can see this wire wound gauges are made up of இந்த wire என்ன மெட்டீரியல்ல பண்ணுவாங்க? So this material, this wire wound gauges are made up of round wire, which is made up of round wire of copper, nickel, and chrome nickel, about 0.0064 centimeter dia, very minute, whereas the length of wire is 25 mm or less. Okay, so this is the things what is inside this material. Okay, now we have to consider the most important factor, the environmental condition. Okay, the environmental conditions which will affect mainly the temperature of the gauge. Okay, and also we have to note that since the resistance is the function of temperature. Okay, therefore the strain gauges are responsible or susceptible to the variations in temperature. Okay, so let me first giving you a small poll so that we can continue in the next class, right? So just mark the poll. Just mark the poll for 2 minutes time. Completed. 1 minute time. One more minute. Completed. So 39 polls. So we can end the poll. Okay, so thank you for attending first hour. The second hour will be tutorial hour. Please be ready, right? Is it clear? Is it clear?
Yes, sir.
Okay.